Well, good morning, March 23rd, the day after spring break that we're supposed to be back in school, but everybody is home, hopefully safe with their families. Stay that way, stay away from everybody. I'll be doing daily videos, and then on Google Classroom, I'll be posting some work for us to do. And all communications then should be done through Google Classrooms. You can ask me questions on there, and we'll have a free and open conversation with everybody that can see. And hopefully we'll learn some new stuff. All right, we got done chapter 6 before spring break where we're graphing trigonometric functions. Now we're going to work with trig identities. So the section 7.1 is going to be verifying trig identities. And we're going to learn some basic trig identities. My best advice to you is to get these memorized as quickly as possible because there's a lot more to come. And basically, the ones that are going to call the fundamental trigonometric identities, we already know. Because we know that the sine of x is equal to 1 over the cosecant of x. And that also can be written as the cosecant of x is equal to 1 over the sine of x. We know these. So the cosine of x is equal to 1 over the secant of x. And that would imply 1 over the secant of x equals the cosine of x. Finally, the tangent of x equals 1 over the cotangent, and 1 over the cotangent of x equals the tangent of x. We also know, really haven't said it, but it's kind of implied, the tangent of x in the unit circle is equal to y over x, which is the sine of x over the cosine of x, and therefore the cotangent, which is the reciprocal of the tangent, would equal the cosine of x over the sine of x. Okay, a couple new, three new identities. The the Pythagorean identities. In the unit circle, my radius is 1, the x value is cosine, and the y value is the sine of x. So that would imply by Pythagorean identity that the sine squared of x plus the cosine squared of x is equal to 1. Very important, used often, please have it memorized. We also have another Pythagorean identity, 1 plus the tangent squared of x is equal to the secant squared of x. You can remember this by I tan for a second. Also, 1 plus the cotangent squared of x is equal to the cosecant squared of x. And I caught a cosecant. So there you have it, your 3 trig identities. Now there's another set of them, simply saying that the sine of the opposite of x is equal to the opposite of the sine of x. And they all have these and they all work the same, except for the secant and cosecant. So it would work for the reciprocal, which is the cosecant of the opposite of x is equal to the opposite of the cosecant of x. The tangent of the opposite of x is equal to the opposite of the tangent of x. The cotangent of the opposite of x is equal to the opposite of the cotangent of x. Finally, the cosine. So the cosine of the opposite of x does not equal the opposite of the cosine of x. It simply equals the cosine of x. In the same fashion, the secant of the opposite of x is going to equal the secant of x. So those are your basic trig identities that you should have memorized. And what we're going to be doing is we're going to be verifying trig identities with these. This is going to start off very easy, I hope, for you. Like I said, it does get difficult for some students if you don't memorize your identities. So, for example, if I had the secant of x times the cotangent of x is equal to the cosecant of x, I would like to prove this identity. I'd like to prove that the left side is equal to the right side. One rule of thumb is start with the most complicated side. So this would be the most complicated side. And I'm going to change everything into sines and cosines. So the secant, well, Yeah, let's go ahead and do it that way. That's kind of a basic rule of thumb. You can do these many different ways, and if you get stuck, be willing to start over and try again. The secant is 1 over the cosine of x. The cotangent is the cosine of x over the sine of x. And now the cosines cancel out. I'm left with 1 over the sine of x, which is equal to the cosecant of x. So therefore, we have verified that identity. And that's pretty much how the nice first ones will work. Let's try another one. Sine of x, tangent of x, plus the cosine of x equals the secant of x. All right, sine of x, tangent of x. So that's going to be the sine of x times the sine of x over the cosine of x, plus the cosine of x. Again, only working with the more complicated side. That's sine squared of x over cosine of x, plus I'd like to add these two together, which means I need a common denominator. So the cosine of x needs to be multiplied by the cosine of x over the cosine of x, which gives me cosine squared of x. So adding the numerators, the sine squared of x plus the cosine squared of x all over the cosine of x. Well, the sine of x plus the cosine is sine squared of x plus cosine squared of x, according to the Pythagorean identity, is equal to 1. So that's 1 over the cosine of x, which is the secant of x. So we have verified that identity. A couple more and we'll be done. Cosine squared of x. Nope, how about just the cosine of x minus the cosine of x times the sine squared of x is equal to, I don't want to get two different problems, cosine cubed of x. All right, so I have two here that contain the same factor. I can factor out a cosine of x, and that gives me 1 minus the sine squared of x. Well, the 1 minus the sine squared of x, that sounds kind of like a Pythagorean identity, but the Pythagorean identity says that the sine squared of x plus the cosine squared of x is equal to 1. Well, let's subtract the sine squared of x from both sides, and that tells me the cosine squared of x is equal to 1 minus the sine squared of x. So the Pythagorean identity you can manipulate to have what you want. So this is now going to be the cosine of x times cosine squared of x, which is the cosine cubed of x, which is exactly what we wanted. Let's try one more here. 1 plus the sine of, let's put a theta in there just for fun, over the cosine of theta. And that's supposed to equal the secant of theta plus the tangent of theta. And you might look at that and say, well, okay, which side is the more complicated side? The truth is neither. And the fact of the matter is you can do these problems more than one way. As long as you use everything proper and get to the final result, you'll be okay. Only work with one side at a time, though. Do not work with both sides. All right, so if we want to work with the left side here, what should we do? Well, I have two terms on the top over one denominator. So if I added fractions together, I would do that and get one denominator. I can break those fractions apart and make them what they were before they were added together. Now, 1 over the cosine is the secant of theta, and the sine of theta over the cosine of theta is the tangent of theta, and that's exactly what we wanted, so it went pretty quick and straight right to it. And if I would have done it on the other side, starting with the secant of theta plus the tangent of theta, we need to add these together, so let's first change everything to sine and cosine. So 1 over the cosine of x, or theta rather, equals the, not equals, plus the sine of theta over the cosine of theta. And you can say, hey, look, we got a common denominator. That's going to be 1 plus the sine of theta all over the cosine of theta. And that would put us right back to where we began. All right, so pretty quick and easy. I'll put some stuff on Google Classroom for you. Please check that. And anytime that you want to ask any questions, please post it on Google Classroom and we can respond then to each other that way. And we will all get to watch everybody's comments and concerns and hopefully get through all this and be back in school in no time. I'll talk to you tomorrow.